Hey, what's up everybody? Welcome back to another 3D Hangout, episode 184.
This week we'll be taking a look at CNC and PCBs, Maker Faire, and a drone claw.
All this and more on, you guessed it,
3D Hangouts.
Hey, what's up everybody? Welcome back to another 3D Hangouts. My name is Noel Ruiz. I'm a designer here at Adafruit, and joining me every week is my brother Pedro.
What's going on everybody? I'm Pedro, Creative Tech here at Adafruit, and every week we come to share 3D printing projects featuring electronics from Adafruit.
That's right, this show we combine 3D printing, DIY electronics, smash them together to make inspirational projects. Hello everybody, welcome to the show. Thank you so much for joining us today. Good maker morning, everybody. Let's go ahead and kind of get some things sorted here. Today we have a coupon code. It is makerfaire. So if you want to pick up anything in the Adafruit shop, you can get 10% off your order if you use coupon code makerfaire.
That's right, works on everything except subscriptions and gift certificates.
You said it. We also got some freebies. Adafruit.com/free. You can get the full rundown on all the free specials that we got going on. It's ongoing while supplies last. We also have some cool delivery options like same-day delivery for fine folks in the New York area. We have CircuitPython meetings every Monday at 2 p.m. Eastern Time. It actually went public for the first time. So if you look at the YouTube channel, we now have a CircuitPython meeting that'll happen every week. It's actually been happening every week for the past couple months or so. Scott has been recording it, sort of like a hangout podcast style. Audio and a little bit of video.
It's a little bit like a show and tell as well, since you do have the ability to participate during the What Are You Working On section. So definitely don't forget to miss that out every Monday, 2 p.m. Join Scott, Katney, Carter, Dan, and everybody working on CircuitPython every week.
On Discord. Discord's the name here. So go to discord.gg/Adafruit.
Yeah, that's also
invited there.
Also a good idea to maybe chat with one of the community helpers there to get the audio and microphone all set up working before the actual show, so you can be ready to go.
Yeah. Cool. We also have some newsletters. Adafruitdaily.com is the place to get your daily dose of Adafruit newsletter stuff. We also have a weekly newsletter that's more product focused. This is adafruit.com/newsletter. So if you want to subscribe to it, you kind of have to because we don't automatically do it. Yeah, so hello everybody in the chat room. This week's project is sort of ongoing. So over the weekend we went over to Maker Faire, our local Maker Faire here in West Palm Beach, South Florida. So we're going to take a look at that, and we'll take a look at what we're prototyping as well. So if you haven't already, we have the video up on the YouTube channel. It talks about, or doesn't really talk about it, it just kind of shows some highlights from the show, from the event, Maker Faire. And real quick, if you want to see if there's a Maker Faire in your area, if you go search for Maker Faire map, you'll find the Make website with an interactive map with all the places and a nice list of all around the world, the Maker Faires that are going on in your local area. So if there's one near your area, try checking it out.
That's right. It looks like the Bay Area one, it'll be coming up next week.
Yeah, not this week, but next week. We have a couple Adafruit members will be there.
Yes.
So that'll be really fun. We'll talk more about it as we get closer to that. But for now, let's take a look at behind the scenes of our trip to Maker Faire, mini Maker Faire, Palm Beach. Here we go. Yeah, so Pedro filmed all this with his new snaps, his new Snapchat spectacles. These are wearable glasses.
Yeah, we'll talk more about this. Some of the things that we saw at the fair, I think it actually should have been the other video it would show, but...
Which one?
It's pretty much the same thing, yeah.
This video?
Yeah.
Well, this is the behind. Everybody already saw the YouTube.
Yeah.
one.
Okay. So the behind the scenes one. Yeah. So we met up with one of our friends here, Perry, who works over at Scripps Institute. Take a look at the wiki page. I can't remember what the info for that was, but they use 3D printing and, of course, a lot of Adafruit products for all of the biomedical research that they do there. He was showing us some of the test tube holders there. We're doing a lot of the shaking, and they're also capturing a lot of data with Adafruit IoT. And one of the cool things was him saying that he literally had 2 windows open. He had noise layer by layer while he was designing the case for some of those shakers.
Yeah, that's really great. It's great to hear that people are using our tutorials and guides in their work. That's really great.
A lot of Adafruit LEDs, pixels. Here's me jumping around in the playground area, just testing HDR for the glasses, which we'll talk about later. That's why I said probably the other video would have been better than this one.
What? This is behind the scenes. This is literally behind your head here. So obviously the science fair here in West Palm Beach is really fun. They got a lot of great sciencey stuff, a lot of interactive things. Most Maker Fairs are held in Science Museum, so no surprise here.
So definitely paid Patreon.
I actually haven't been there yet, so it was a lot of fun for me to go there because I didn't get to go last year. You went last year, had a lot of fun as well. This year I got to go, got a little video, and it's just a general good time. Yep.
Yeah, again, this was all showing the HDR and the detail quality from the new updated beta data bit rate for the video, so that's why the other video
they had Kylo Ren. They had the 51st squad there as well.
A lot of servo action using, of course, the Adafruit Pi servo controller, the 16-bit controller there.
This is with DOI ice cream. I totally missed this. Like I didn't even see any of this.
A lot of CNC
pen plotter. That was always fun to see. You had sort of a sorting bot. That's always cool to see. Just being driven by a stepper motor and a light sensor. He also had some more traditional makey stuff, like building a surfboard.
Did some little gardening stuff as well. Of course, he had Star Wars building lightsabers, which of course we're going to have to add since we've never done a lightsaber project.
Yeah, Lamar emailed us saying, hey, you should do a lightsaber project.
A lot of drone stuff, some inspiration for the drone claw that I'm working on, so we'll take a look at that.
How is that being suspended? That was cool. A lot of 3D printing. These are a lot of up minis. We got some not Ewoks.
No, they're Ewoks.
I don't know what they're called.
They're Ewoks.
Oh, they are Ewoks? No, they're not Ewoks. Ewoks are the fuzzy ones.
Oh.
Sorry. We don't have super nerd knowledge of Star Wars. Anyway, it was fun to see a lot of 3D printers there. These are the make.
A lot of ceramic, clay.
Yeah, also different things, yeah.
Big prints, paper, and fish.
A lot of fish.
Because, of course, it is
as a low aquarium as well. Yeah. That's cool. Good displays. Yeah, it's a good size. It wasn't like this huge place you can get lost in. So that was nice. And there's a lot of kind of magnet schools and after-school programs there as well that were showcasing their kids, or really their students' work. So it was cool. They had a lot of Lego EV3 stuff, and of course they had a putting range. So why not do some putting?
We'll break from that in the nice, super hot Florida sun.
It was nice and breezy though. We did see one cool CNC router bot here. It's not a handy bot, but it's like a router.
Nice little wall CNC, so you can cut some big stuff.
One
of the cool things that we were also interested were the ROV, underwater robots here.
Yeah, those are really fun. So they had sort of a little mini game where you would pick up those things.
Rings and
put up rings, kind of like
a little obstacle course and stuff. Of course, they had woodworking stuff for kids.
Yep.
Gavin had a little fun making a nice little plane there out of wood.
Yeah, they had it set up really nice. So like the big kids could cut their own pieces of wood, but they also had pre-cut wood, so kids could just kind of focus on hammering things together as opposed to cutting their fingers, maybe. So that was a lot of fun.
So a lot of fun. Definitely recommend checking one out in your area. And I think it cuts here for the makerfaire stuff.
Yeah. Yeah, and just overall kind of testing out different lighting conditions with
this is why this was supposed to be the next one. Okay, so lots of fun, of course. Check out the full video. That was just behind the scenes stuff. And of course, you use coupon code makerfaire.
Yes.
Grab any of those. A lot of those projects, of course, are open source, so you can get like the shaker is all open source. Of course, the liquid holder, the tubes for that.
Yeah, their own Thingiverse, I believe. Sweet.
Nice set of instructions there on Perry's website as well. All linked in the description to the YouTube video, so you can check those out.
That's great. Cool. All right. So that's pretty much what we wanted to share. We have some stuff we're working on. So what are we prototyping?
Yes, let's go ahead and jump into this very awesome PCB that you've been working on for the Circuit Playground Express.
Yeah, you want to turn it on for me?
Let's see.
Yeah, so a couple weeks ago I was showing you guys some PCB designs that we're kind of playing with. So using EagleCAD and the Bantam tools desktop CNC. So I kind of wanted to make a board with kind of a different shape because I wanted to do that. The exercise was kind of how do I get a custom shape out of Fusion 360 and into EagleCAD. So this is running CircuitPython, and this is of course Circuit Playground Express. And it's using capacitive touch library and the tone library, so you can make some tones. Not sure if you can hear that so well. It's pretty responsive for what it does, so that's pretty neat. And made a little 3D printed case for it. Well, it's more like a holder. And this was of course CNC milled on the Bantam tool CNC. So what I'll do is I'll show you guys the learning guide. So this is actually from Katney's project, Circuit Playground Express, Piano in the Key of Lime. So this is sort of our version of sort of like the traditional, not traditional, but the thing you see mostly with Makey's is like the fruit piano, right? So it's kind of doing that, but because Circuit Playground has so many sensors and has a built-in speaker, you can kind of do all that without plugging it into a computer. You can just plug it into a battery via USB and make a little capacitive touch piano. But in this case, Katney's using key limes as the fruit. So that's cool. So I was playing with that, and I just kind of thought, hey, it'd be cool to, because I've seen people use copper tape and things to make like a custom like little kind of setup for playing tones and stuff. So I thought it'd be a really good exercise to make a PCB adapter that had like these little appendages or fingers that would spread out. Because I thought I'd make it a piano, like a traditional piano, but we can't really do the whole octave. So I figured I'd just make these little fingers that kind of stick out from the bottom. Yeah, and again, the main thing here was to, like, how do I get a shape out of Fusion 360 and bring it into EagleCAD? That way I can make these custom shapes, just get more experience using EagleCAD, which is the design software that we use here at Adafruit to design all of our boards and stuff. It's a free download, and it works really well with Fusion 360 now. So I've been doing a lot of that, and I'm working on a guide and a video that will hopefully be out next week that showcases this design and the other designs too, the more practical one of getting the Circuit Playground to work so you can plug things easily to it instead of using alligator clips. And the way this is attached is just with M3 screws, so you can see the screws here. And no nuts needed for this one. The PCB breadboard adapter I made did have some nuts just to kind of secure the two together, but this one didn't need it. So that was cool. I got a battery back here, so it kind of tends to shut off every now and then. It was a lot of fun. I also spent some time in Eagle and put together a little library object of the Circuit Playground of the pins, because the pins are, you know, these big giant pads. They're kind of custom designed, so the positioning of them are a little very unique and very in specific spots. So I had to really break that out into its own library so that I can reuse this object in EagleCAD if I want to make a new PCB, which is really helpful for making this. So first thing was to make the library, get the pinouts in this spot where I can just copy and paste them and just place an object onto EagleCAD canvas and then just kind of route and make all sorts of different board shapes. So that was really cool. I got some, here's what it looks like outside of the board. I kind of worked with two different methods. So this first method is just kind of the quickest way you can mill, is where you just cut the outline of the traces. And then something more like this. This is with a giant clearance, basically saying I want to mill away everything except the copper traces in the touchpad. So you can see here, this is what the board looks like bare. And it's just a single-sided FR1 board. They're pre-cut for the other mill, or the Bantam tools, desktop CNC. And what I like about this method is that you are going to get less bridging. So if you have, you know, if you have like touchpad points, you might bridge something touching these blank pieces of copper. Whereas this one, you only have the traces, so you're less likely to cause any bridging. So that's really nice. And the traces are pretty thick. They can obviously be really, really thin. They can, I think the smallest you can make it is like 6 mil. These are like, I don't know, like 20 mil or something crazy. Not millimeters, but mil. And I'm just trying to play with the focus here. There we go. Maybe that'll focus better. Yeah. It's already starting to kind of oxidize a little bit, so you could either Scotch-Brite that, or here's another look at kind of how over time it really gets oxidized. So using solder mask obviously is a great way to protect this from oxidizing. But again, testing out milling away everything, this is less prone to oxidize because there's just less surface area to oxidize, so that's cool. M3 holes here, and yeah, it's pretty neat. So again, we'll be putting together a nice learning guide and have this available to either download, mill yourself, or maybe purchase. Shout out to Dave Estells, who really kind of inspired this project. So Dave's actually put together a learning guide on how to kind of construct your own Circuit Playground shield. He calls it a Circuit Playground biscuit, which is a really clever name. And he kind of shows you how to make your own with a perf board using standoffs and M3 screws. He also made his own custom PCBs, which I think he's going to start selling on Tindy soon, if not already. You can check out the links down in the description, and also on Discord, and he's also on Instagram as well, so you can check out Dave's work there. So awesome. So again, we'll have a video about this next week, and also wanted to show you guys just kind of a quick rundown of the process. So bringing this into Bantam tools, that's the software, the G-code interpreter for the Bantam tools desktop CNC. It's really awesome piece of software. There's like very, very minimal setup for getting an Eagle board into the software. You literally drop it in, and it gives you a render of what the traces look like, so you get a visual idea of how the tool paths are going to be. Their material profiles are already pre-made, so you don't have to worry about speeds and feeds settings. You don't have to worry about Gerber files. It takes a native EagleCAD board file and just does all of the feeds and speed settings for you, which is really great, because then you can just quickly focus on the actual design as opposed to like setting it up and things. So it's really nice. And it's a single-sided FR1 board, so it's a lot easier to do these than the double-sided stuff, because 2 weeks ago I showed you guys how I put together the double-sided version. This one just cuts the time in half. If you don't need double-sided, why do it? So I figured I'd do it like this. It mills in like, I want to say like 5 minutes for the first version, and then if you're milling away everything but the traces, it kind of doubles the time. And I've been cutting so much that like my tool's getting really dull, so I need to I need to go buy some new tools. So this one really kind of shows how really, look at those edges. They look really rough, right? I figured that like, oh, that's totally a fail. There's no way I can fix that. But it's crazy what some Scotch-Brite can do. So light sanding on this using this scoring pad really knocks down all those burrs and smooths it out really nice. That's what I find myself doing a lot is like right after the milling is done, I'll just lightly sand it with a Scotch-Brite pad until all the burrs are gone. Because it's like, why do it after you take it off the bed? Because I still need to cut the holes and things. Or actually, no, they're already cut. But in any manner, using the alcohol trick is really nice to get the double-sided tape to kind of soften the adhesive. I was playing around with different cutting depths so that I could, because before like I wasn't cutting deep enough, so I would have to like use an X-Acto blade to kind of cut it off. But this worked out well, just kind of increasing the depth cut from 0.15 to I think 0.18 millimeters. That worked well. It's always a little bit variable because the thickness of your tape is, you know, kind of changes if you're using different tape or whatever. Still had to punch the holes a little bit with an X-Acto blade, but it's not too much processing at all. Very hands-on, so with anything like cutting or milling, you gotta do a little bit of cleanup, a little bit of post-processing. And yeah, it's just the way it works. You line up the mounting holes and just use some M3 screws to secure them together. And yeah, it works pretty well. Yeah. I like that the colors are kind of match the tones, like C for red and that sort of thing. Yeah, so that was neat.
Super cool. So you have this available to downloads, and everybody can pick these up, as well as the Fusion 360 files, so you can actually mill out your own shapes if you want to fit it into a custom enclosure, as well as the enclosure itself. So definitely check that out. All the links will be in the description. If you guys want to pick that up.
Yeah, as we get to it, we don't have anything out yet, but that's what we're working on. Yeah.
Super cool.
So if you guys have any cool ideas for custom PCBs, let me know. It'd be fun to mill out some community designs or something. That'd be really cool.
Yeah, I think.
And if you're interested in picking up a Bantam Tools, you can go to their website, bantamtools.com. That's where you can also download their software for free to see if your Eagle board, how it'll look like in their software. So it's free download. Check it out. There's so many different things you can do with CNC milling. It's kind of like a superpower, especially when you have EagleCAD. Yeah.
Plays the tune.
Plays the tune. Well, I kind of already did, but yeah. I noticed some of the pads like to get stuck. One of the cool things that Kattni wrote in here is that you know there's only 7 pads, but you can make an 8th one by hitting 2 at the same time. So you got C, D, E, F, G, A, B, and then if you hold down A and B at the same time, you get C5 instead of C4 or C3, whichever one it is. So that's how you can kind of do that. It's pretty neat. So check it out. The learning guide is already up if you want to start doing capacitive touch tones. So you can go to the Adafruit Learning site and check out Piano in the Key of Lime. Shout out to Kattni for sharing that.
Super cool. So this will be, I think, next week. We're going to get to that. Very awesome. Go ahead and take a look at some of the things I've been prototyping. Continuing on with the drone claw. I think I showed off a week or 2 ago. Finally got the mounting for the legs figured out. So it's a simple little attachment that goes to the existing legs that are on there, which are quite handy since the clearance for the Mavic Pro, which is what I'm using on this, is pretty low. So definitely a good opportunity to increase the size of the clearance for that, especially for when you're like on terrain that's a little bit more bumpy. Or give it more time to raise up off the ground to give it the ability for the gimbal to stabilize. A little bit big to see here, but we're just looking at the drone. The foot here, the back legs is where the claw is going to attach to. And the way that this is working is using the light sensor right on the Circuit Playground Express. When you turn on the front LEDs for this, we're using a piece of PET filament to act as a light pipe. So as soon as it sees the light coming through, it'll turn on and open up the claw. So I'm going to do a live demo here, see if this works out.
Okay, so you can trigger the lights from the drone via the DJI app and the remote control.
Yeah.
So as it's in the sky, you can actuate the servo by just remotely turning on and off the LED from the front.
Exactly, yeah. So there's a couple of different turns that I've had to make with designing this. So it went from having the entire thing being powered by the micro USB that's on the side here, but it turns out that like some of the USB batteries, like the battery bank here,
yeah, it just stops powering.
Yeah, it just stops giving it power after a while, which is kind of weird since the past projects where we've had the drone feed it power, it stayed on. But like you were saying before, it's because we had NeoPixels on that.
Yeah, consistently on. So if it's like in sleep mode or not drawing enough current, the battery will just kind of shut off.
Yeah. So that's what's going on here.
Hey Kirby, you forgot it was Wednesday. Yeah, it's one of those weeks.
So let's see if I could test this out by just turning on the front LEDs on for that.
Okay. And is that something you set up in the suite?
Yeah, so all that's going on is, again,
it's really awkward
big,
to
yeah.
show. Do you want me to like bring the camera down or?
Yeah, let's see how that works.
All right, so here's the...
There we go. You can kind of see operating there. You can see the light right here. So all I'm doing is I rerouted the front LEDs to turn on to one of the customizable controls, or it's on the bottom of the controller here. And that's all I'm doing. I'm just turning the LED on and off, and we're using the PET filament as a light pipe. So I got a little hole that's right here. It's blocking out all the light.
Yep.
And it's simply just looking for that, all made in Make code. So you get this easy and up and running real fast. And one of the things I'm impressed by is the speed at which it's able to process this. Usually with like interpretive languages, it takes a little bit to actually process something, but this is really speedy.
Yeah, they got the bouncing or something figured out really nice.
Yeah.
All right. Okay, don't break it. You're not going to be doing that. So what are the plans to kind of deploy or drop or...
yeah,
more of a concept.
More of a concept. With hurricane season coming up, it's definitely going to be something that you can use for, I don't know, delivering goods or something like that. Although I don't know what
or something.
I'll have to look up what the maximum payload that you can carry on a Mavic Pro. But basically, that is pretty much it. Some of the other kits that are out there.
I hope so.
I know that's actually what we're testing right now.
Yeah, after the show, we gotta go and fly it.
Yeah, so some of the stress tests that I've seen for the Mavic Pros is like water bottles being lifted up, and it was able to handle that very well. Yeah, so that shouldn't have any problems with that. And the grippers are obviously can be customized to something else. I think I'm going to modify these, so because as it is right now, it could grab, I guess, a Circuit Playground Express to do the egg drop project, since we are going to split this off into several other projects. But I think the way that I mostly see people carrying things is like it's like attached via a string to something else. That's the actual payload that you're carrying. And we look at the overhead. One of the other things that I want to highlight too, the things that we've been testing, is the Breakaway support material, which I use for this. Because of the odd shape that the way that the back legs are, where the motor is mounted into, you'd have to use support materials for that. Because I didn't want any of the PLA supports getting caught or messing with the depth of where the nut actually goes into, the Breakaway support material did a really good job of being able to alleviate any overhang, and check out the quality that you're getting with that. This is type of projects where the PVA would be a little bit more time consuming to dissolve away, because you do actually have to scrape away at it to actually get a lot of it off, because it does tend to fuse a little bit with the material that you're printing with. But the breakaway stuff, you're able to cleanly get that off without any waiting for it to dissolve away. You just rip it right off. You can see the quality that you're able to get on that. All of this right here was all printed on top of it, and it did a really good job.
Yeah, so what's breakaway? You keep saying this word, I don't know what it is.
So Breakaway Filament is pretty much, I can't remember the other guys who make something similar.
So this is from Ultimaker. Like that. This is a new type of material that's specifically meant to be an alternative to PVA support. So it's meant to act as scaffolding, so support material. It's got some properties to it that allow it to work really well with PLA, ABS, and some of the nylons. So it's a special blend of like copolyester. And the cool thing about this is that it prints with regular PLA settings. So if you have a dual extruder setup, you can print some crazy geometries and have some floating, literally like some floating geometry, some 90-degree overhangs, and have them come out, have the bottoms come out so good that they're better than the top of the print. So in this case, I put together a little wireframe pipe that interweaves and intersects with itself. So we're really testing the capabilities of this filament by doing this sort of stress test, because it's not really meant to do sort of delicate things that interweave into itself and all this complex geometry. It's sort of like in between using a PVA part and a thick, really chunky part, because that's kind of what they're touting. If you go to Ultimaker's website, they have a couple examples of what breakaway breakaway is meant for. It's meant for like industrial parts that are kind of big and chunky and aren't delicate. This kind of weird shape is not really what it's meant to do, but it did it fairly well. We also printed it with this week's Time-Lapse Tuesday, which is a planter with like sort of like a floating floating sphere. So this is a big use of it. As you can see here, it's very tough, but it's really good, right? So tell me about this, because you got this one.
Yeah, so just some adjustments that I had to do there, because it did fuse with it. As you can see, I actually broke the part trying to get that off of there. So just increasing the Z depth on that with a bigger nozzle size, because I did use a 0.8 mil 4mm layer height for that as well.
It's big, right? Because it's a big planner. We want to print it as quick as we can. The quality doesn't really matter that much, like the layer height, although it looks like it's already been sanded or something. So Breakaway Material, it is an NFC chipped spool, so the Ultimaker recognizes it. There's already profiles set up for it. All we had to do is change a little bit of the Z distance, which is what anyone wants to do when you're printing support material.
Yeah, so if you go to the overhead here,
take
a look at the design detail we were able to get off of this. And you were mentioning that the bottom actually looked a lot more better than the top here. And you can see how well this was able to print on it without actually fusing to it. Get some shine on there so you can see the layers. There you go.
See if I can get a little bit. There you go.
And again, this is the bottom of that. So the interface layer that is printed on top of the infill to get a nice smooth bottom for that.
This is incredible. Like you can see this.
So this is the top.
There's quite a few. Yeah, there's quite a few features on this thing that are floating. Look at the corners and how straight they are, and the edges just are really, really sharp. There's no real fillets on those edges, other than the corners. But that is the bottom. Like look how great that looks. It's crazy.
So they did a really good job of there.
This took about 7 hours to print, though, right? Is it?
I think it was about 6. Yeah,
6 or 7 hours.
We have a time lapse of it.
Yeah, we still got to process it, but this is our first kind of test with Breakaway, because last week was all about experimenting with PVA, the water-soluble stuff. Breakaway, it has its own benefits, right? To where it's a little bit quicker than PVA, because you don't have to sit there for days.
Especially for this print, because it did take about a day and a half, almost 2 days to fully dissolve that material, and this was with me ripping off a lot of it and just leaving what was actually what it was actually supporting the closest to the sphere part.
Yeah.
And it still took about a day and a half. I actually had to go in there and actually scrape away.
So this is PVA?
This is Breakaway.
Okay, but there's some scuffs because it was too close to the print.
Yeah, it was definitely too close. So that's
the Z's
a
distance.
note to keep in. A note to keep in mind if you're printing with a wider nozzle, a higher layer height. So in this case, it was a 0.8 millimeter nozzle printing at 0.4 mil layer height. You do want to increase the distance, the Z distance from the support material, so it'll back away from it and not fuse with it. So you can kind of see that in between each layer that's where the Breakaway was. So it was literally fused and became part of this model.
Right. But test number 2,
which we're kind of all over the
there's
place
the gray
now,
one. The gray one.
Time lapse stuff for this.
The gray one. Isn't that the more
grab the
appropriate?
gray one. This one was with PLA or PVA. You can see this did a really good job.
Okay. Yeah, but this took forever to dissolve in the water.
Yeah.
So there's the bottom of it.
The underneath.
All of that was printed just floating.
The focus on that.
Yeah, of course.
Can't get too close on this one. Yeah. There you go. So did a really good job. Only a minor bit of warping that happened.
Yeah, like
right
it shrunk
here.
a little bit.
Yeah, but that might have been because of the layer height. On the actual one the wooden one that I used, I lowered it down to 0.3 layer height.
This is crazy. I mean, it's huge.
Sphere printed in the air. So if you ever wanted to print a sphere or something that had a crazy amount of curve with supports,
what would you?
PVA.
So what one here? What was better, like PVA or Breakaway?
So
for this particular model.
If you're trying to go with speed, probably Breakaway. Just increase the Z distance on that.
Yeah.
You should be able to get a very fine, smooth surface out of that.
Right.
So definitely the Breakaway, I would say, wins in this situation.
Right. Remember, PVA was super critical for a D20 inside of a D20.
Yeah, if you're printing things that are inside of each other,
you can't get in there.
You're not going to be able to get in.
This, however, is in between too intricate but still hardy enough to survive.
You can still get a tool in there.
Yeah. Yeah, and I kind of designed it around that, like thinking.
Yeah, it's got like
how can I still get in there?
Thickness, so nice and strong.
Yeah, so it's all one unified 3D sketch in Fusion, and then just using the pipe tool to extrude it out like that. And it's pretty thick. It's about 4 millimeters thick, the pipe itself. Yeah. And then you can even see some of the edges where dual extruding gets a little messy. So there's like the kind of ugly side, right?
Yeah,
but you can fix this.
We didn't use a prime tower for that, so that's an important point too.
Absolutely,
so a lot of oozing did happen on one of the sides.
Yeah, it's to kind of eliminate that so that it has more time to purge. This one didn't purge any; it just like switched right away.
Yeah.
What about this one? Did this one have a tower? No.
This one did have a tower.
Oh, it did.
Yeah, this one did have.
So that's why there's less kind of bad spots, I would say.
Yeah.
Yeah. And this isn't sanded at all. This is just the wood filament. The texture on it just kind of blends the layers together. Or at least in the top section, you can see it's a lot more smooth.
And then you can go to the full overhead to see the entire planter of what that looks like. And did a little. So there's a little bit of like a color change underneath here, and I think that is probably PVA that has not dissolved yet. So I'm guessing we'll take a look at it later once we place it outside, and it's outside with the nice humidity and the weather, and maybe it'll melt away. But that's the only thing only blemish that I see left behind with the PVA version of this print. But otherwise, it looks really good. It's all nice and smooth. No additional sanding. I could have stained it, but I just ran out of time for that.
Okay. We got a question. Apt Pupil is asking, on the sphere, what type of support structure did you use? What type do you normally use?
So for this one, the pattern for infill was triangle.
Triangular pattern?
Yeah, triangular pattern, and then...
So it's not zigzag?
No, it's not.
Okay.
So if you go over to Cura here...
Go on to the Cura bubble. If I can set the screen. There it is. Here's Cura, guys. And under support, Support pattern, triangles. Which one do you use?
Triangles is what I tend to use.
Triangles. All right, so that's default. This is default Breakaway profile, the material profile. The only thing that I changed was the support Z distance. You have to turn this on. There's a little gear right there. And then right over here, this is all the stuff that pertains to the support category. There's a lot of different things, but the one that you need to work on is support Z distance. That's usually turned off by default, or at least not visual. It's not layered. It's turned off. So it's at 0.4. By default, it's at 0.2, but it's at 0.4. If you have a bigger nozzle, so you have a 0.8 nozzle with a bigger layer height, you want to up this to like maybe 8 or 6, something like that.
About 6 to 8.
6 to 8.
I recommend.
Yeah.
Again, depending on the geometry.
Yeah, and you want to have enable support, but support interface, leave that on, because that's what catches those bottom layers really nice. And you can see here in the render under layer view, you can see it's kind of amazing how the support interface layer is floating. You see the geometry in here? Like that corner is floating right there where my mouse is. Like it didn't have much to catch on, but of course it's a couple layers thick, and it's catching itself via kind of like a fillet. It's almost like a chamfer as you see it kind of building up there. The yellow material, which is the PLA, catches itself here, and that support interface is what's allowing the first layer to lay down like so nicely, as you can see here as you're stepping through it. So that's really cool, and it's not that much infill. It's what, 10%?
No, it's 10%
infill.
Yeah.
But which
is why I like the triangular infill for not only support materials, but as well as just regular object material. Depending on the geometry, not all of it is ideal when using triangular, but for the most part it is. So definitely check those out. Definitely go through your toolpath to make sure there aren't any irregularities or not enough infill in there.
I'm still amazed that the interface layer was able to catch itself and kind of work really well, where there's no warping or any of that.
Yeah, again, this was test number 2 that we did.
Yeah, and of course there's a big brim at the bottom to keep the adhesion really well.
Again, so because of the geometry, it is very little footprint that is on the bed for it to adhere to. Yeah. So we wanted to make sure that we increase that.
Yep. Any other questions that I might have missed?
The Z distance was 0.4 is what we increased it to.
Yeah, 0.4.
Pupil was asking. That's right. So about 0.2, 0.4, and if you're using a bigger nozzle with a larger layer height, about 0.6 to 0.8.
Yeah, by default it's 0.2, which is a little too tight.
It could fuse, depending on what you're printing.
Yeah.
So now that we've already gone into that, showing off the Time Lapse Tuesday, really cool design.
Let's show the video real quick.
Yeah.
As that works. So yeah, this was printed with Breakaway. No, PVA.
So this is a PVA one, yeah.
Okay.
This was before we got the Breakaway in.
Oh. It looks similar, doesn't it?
Yeah,
the color.
And 0.3 layer height, as I said.
Look at this time lapse of it melting. This part right here, ready, set. That's crazy how it just dissolves like that. It's a lot of PVA as well. So we were like, well, that's not a waste, but that's quite a bit of PVA. What's a better alternative? Breakaway.
Yeah, so what's not shown here with the gray version of that, I did remove a lot of the tower and then let that dissolve, and that still took like a day and a half. So, and this was with scraping away at the bottom of it with a little spudger tool. Right. I tried to remove a lot of that PVA away, and it still took that long.
Wow.
But of course, the quality you're able to get out of that might totally be worth it. Again, so smooth.
Yeah, I think somebody in the comment section was like, "Hey, that's sanded." It's like, no, it actually isn't sanded at all. Yeah. That's just what it looks like. Wood filament. It just kind of gives you that texture. I mean, you can see here. There's a little bit of ringing there, but nothing too bad.
It actually looks really good when you apply staining to it.
It does.
It makes it look more like wood.
More like wood, yeah. Interesting planter design, by the way. Shout out to Thingiverse user Footmix on Thingiverse. He shared this.
So he calls this the Cobra planter.
Yeah.
Which is very appropriate for, snake theme, CircuitPython.
Oh, that's funny.
Should have put Blinka's
Yeah, pretty neat little
characteristics
shape
on there.
I like the curvature of it and all.
And
Cool.
and this is a series too, so he's got 2 other really cool designs you can check out.
Yeah, quite a few makes.
Mm-hmm.
Yeah, really cool.
Doing a good job.
This is a really cool one, this make here. It
Oh
looks
my
like
god,
it.
yeah. Check out the post-processing on that
Yeah,
one.
that's amazing. Looks like clay or something.
Wow.
Anyway, very cool work. You can check out the Thingiverse thingy right here. There you go.
Yeah, Pupil is saying that he's been having issues removing supports.
Oh, yes.
That is the #1 thing, support distance. At least check on that.
That's right. Yep. You were going to show this off as well?
So this is the next test that we're checking out for doing the breakaway stuff.
I'm working on
And
it.
this is the perfect application for this, where you do want like a curve to be on there.
Yeah.
Like some of the people who have been printing this out have been sinking it into the bed, so they get rid of that curve. But that eliminates the clearance that's needed for the standoffs for your screws to put this. This is a light switch cover if you haven't figured out.
Yeah.
With Lego studs on the front. So of course you can't print this, with this laying down on the bed, because all your studs are gonna, you're gonna have a lot of overhang for each, in between each stud. So this is the type of, geometry that they actually
show it closer.
This is the type of geometry that they showcase for breakaway usage, where it's just a huge roof that you need to catch.
Yeah.
So say we try to remove this live,
Yeah, you
just
want
a
to
little bit of it, just to see what the underneath is going to look like.
Right.
Let's go ahead and take a look.
Yep. So if you were printing this with a regular PLA printer, you would probably want to separate the 2 parts, right?
Yes, that's actually
And
what I
then glue
did
them
before.
together, and that's what we would typically do. But with a dual extruder setup and with support material like the breakaway stuff, you kind of aren't limited. You're no longer constrained to kind of optimize for printing without supports. So printing with supports is like a whole new world. Excellent live support removal. Yeah. So tell me, what's your technique here? You twist
So
and
I'm
pull?
trying to get, I'm trying to grab as much as I can by inserting the flat pliers into the crevices here, because there is a little bit of a Z distance on X and Y as well.
There is, yeah.
So you can kind of see how
The,
it's not effortless, but it is a little bit more easier than regular supports.
yeah. Okay.
And if I also take one of these tools here to sort of get underneath it,
Oh, that's good.
see
yeah.
how clean the bottom is here.
Yeah.
Oh yeah, it slides right underneath.
Sweet.
And wow.
Oh my
Take
goodness.
a look at that.
Dude.
One of the comments that I said in one of the snaps that I posted is that it feels like that string that is on balloons definitely has that feel.
The ribbon.
The ribbon,
sort of the ribbon material that you would see in balloons. Yeah, it feels like it a lot. It's kind of weird. Maybe it's the same material.
Let's see. So we're peeling off here the support interface. I don't know if you're able to tell, but this comes off very...
It peels off pretty well.
Yeah, it
There's
peels
no
off.
fusing here.
Wow. Sort of like removing the plastic from a screen
A display, yeah.
display. Looks like it's a little bit more stuck on some of these.
Okay. Oh, well, it didn't leave behind any... Oh, gosh.
Looks like a little bit was left behind right
Okay.
here. You fully get all these off.
Nothing that would affect the functionality of the part, I think.
Yeah, it's more...
Yeah,
like
it's a
oozing.
beautiful thing when the whole bunch comes off at once, yeah.
Oh my god, yeah. You know all those videos with the soothing, what is it, like making
surprisingly
clay?
pleasant? Or,
Yeah, surprisingly soothing or whatever.
Yeah, something like that.
This should totally be on the list. We should make a bunch of those. Get right near the
That does
end
kinda
of
look
all
like a
this.
cassette tape.
Oh, it did, yeah. Again, I'm trying to rush here to...
Over the camera, it looks really blended well. Like you can't see any of the of the kind of texture yet. It's just kind of all seamless right now. There you go. Let's see if we get closer. Oh, there you go. It's pretty flat. There's no kind of overhanging. There's no string.
Looks like I might be able to get rid of some of this with a bit more work.
That's fine. I like that it's white and red. It's a really good contrast there. The Breakaway material only comes in one color, I think.
Yeah.
Maybe two colors.
I don't know why you would want a different color. But yeah, check it out. This is the only part that actually fused to the back here. But overall, it's nice and smooth. There's no like bump over it. Looks like it's part of the material.
See if you can get some light reflection on it, like shine the. There you go. Yeah, that gives you a better idea of the texture of it.
And it did a pretty well job.
Yeah.
Oh. Nice and flat. There's no real bump on this.
Dimensionally kind of stable, accurate, whatever.
Yeah. Grab a little AdaBot here. All the studs worked out.
Oh yeah, right.
That works. Super cool. Yeah.
Cool design. It's on Thingiverse. Should I pull it up?
Oh yeah, you can pull it up. Looks like we got to print more of these for some of the other light covers, the switches.
So again, what is in the Breakaway material? There is a materials data sheet that we have to look at, but at the top of our heads, we don't really know yet. We haven't looked that far into it. We know it has a longer shelf life than PVA.
Yes,
that was another feature point.
Water or moisture.
Yeah, so it has a longer shelf life. It works with regular PLA settings.
Yeah.
So we gotta imagine it's something that might be copolyester of sorts.
Mm-hmm.
And it's about 750 grams, almost a kilogram, for I believe 60 to 80 bucks. It's a little bit more pricey than regular PLA.
Yeah. But I'm gonna assume that it might be close to what the poly support material might be. So maybe, we'll have to get some of that in and test it out.
E3D has some as well called scaffolding. I wanted to try their stuff. I couldn't find any though here in the States.
So
but yes, it is explicitly sold as Breakaway material. Yep, I mean it's called Breakaway.
Yeah.
Very cool.
So this has definitely been fully integrated into our work process now.
Yeah,
anything that is support material related, we'll be using PVA or Breakaway or any of the other support scaffolding related materials going forward. Since the look at you're able to get out of it and the dimensional accuracy that you're able to keep with the scaffolding support materials, like very like it's going to give us a lot less headaches in terms of getting geometries that'll fit our components a lot more better for projects. So definitely something to
This is really like the kind of highlighting key point features of having a dual extruder setup. Extruder. When we first got it, we were first experiencing it was mostly about color, mixing colors together, mixing different materials. Maybe we wanted, flexibles and hard PLAs. This is that whole other area of like geometry and supports, being able to dual extrude with just support material, specific support material.
Very awesome. Yeah, we'll continue to do more tests on this. We'll get other materials that are supposed to be like scaffolding materials to see what the difference is price-wise, and of course how they're able to work within deadlines and all that. So definitely exciting times for support materials.
And as a designer, like no longer being constrained to optimizing for no supports. Like that's been my whole thing from the beginning, and now it's like kind of thinking outside of that and like figuring out like, well, I can print this out like this.
This is where it really mattered, because I didn't want to have this on the outside. I didn't want to change the geometry of this leg,
or have to assemble pieces into one sub-assembly. It's like, oh, let me just print it all at once.
Especially if it could be combined together to, one, make it structurally more stable and more stronger that way. So,
Yeah, and one of the things that you might, well, why don't you just use PLA supports? You could just use PLA supports.
Again, I don't want
fusing. But the thing is, you actually get fusing. No matter how much of a support distance, you might have a little bit of scarring here and there.
Yep.
Yeah, especially with something like this bottom that you were showing. Like that's a hex nut shape. It's a hexagon. It's not a circle. So it has to have these kind of sharp
And because
edges.
it's printing upside down, I don't want that to droop down, and then I have to like increase the tolerance on that.
Yeah.
And change the geometry just because we would have that happening. Okay.
Sweet.
Definitely check out some of our behind the scenes for more tests on that. Got our
This
Instagrams
Breakaway.
for all of that.
All right, we got a little bit of time left. I want to give a shout out to Colin Cunningham.
Who has a new
If you
guide.
go to if you go to Learning System, Colin's latest guide is about the Nintendo Labo, the ToyCon Piano build. Here's how you can make a light effects kind of visualizer for the piano. So he took a circuit playground and he wired up one of our electric mics and basically made like a UV meter with a circuit playground in the Nintendo Labo. So that was a really cool guide. So he shows you how to wire it up, how to upload the code via CircuitPython. There's a CircuitPython code. Takes the analog inputs from the microphone and makes some really cool lights. Here's how to stuff it in the cardboard and get this cool kind of organ, colored organ type deal. Very, very cool. So doing some more cardboard stuff. Over the weekend, I put together the piano thing finally. Because last weekend, Pedro put together the house thing. So this was a lot of fun. I had a lot. They've done such a really good job with their document, their whole like app and their little videos and their walkthrough guides of how to put this stuff together. It's really fun and informative too, very educational as well. It's telling you how it works, how the IR camera works. And they have like this special sort of like demo app that shows you sort of the raw data of all the little markers.
Oh wow!
All the little IR markers that are on the bottom of the piano keys. That's how it knows where it is, and it talks about reference points, reference markers. Yeah, it's pretty cool. Yeah, really cool. Great job, Nintendo.
And then one of the projects that PT suggested are 3D printed waveform cards, which I still don't know. What is this?
Yeah, so one of the cool features with the Studio app, it's the app that lets you play tones and stuff, is that they give you a couple of pre-cut cardboard cards that you can the Joy-Con will actually scan the card that's inside, because you like insert it in the box and it scans that, and then depending on what the waveform is, it'll actually make the sound into that waveform. So whether you got a triangle, a square, or a sawtooth, those are all the different shapes. This gentleman here designed his own and 3D printed it. So he made all these different types of shapes, not just kind of your buzzy shapes, but also like acoustic shapes. So like the clarinet, for example. So here's a little GIF of all the, and he kind of labeled them. Yeah. Sawtooth, shine, organ, clarinet.
That's excellent.
It actually sounds like it too. So it's really cool. So I got to 3D print these. He, of course, gave the download away. So you hit this button and it scans it. It's kind of cool. Like when it scans, it starts vibrating and goes.
The thing that blew me away is that I thought this was playing through the speaker, but you say it's actually the Joy-Cons.
There's a mode where you can use the Joy-Con to make the acoustic sound. That's a separate. That's separate sound or mode. Yeah, really fun, man. They did such a cool job with this.
Amazing.
Yeah.
So be on the lookout for more
Joy-Con stuff.
Nintendo Labo projects, and of course more.
Yeah, this is on the
Cobra
blog
projects
as well. PT and Colin put this on the blog, the Adafruit blog.
Super cool. All right, I think that's we're getting near the end of the show.
Yep. One last thing. Did you want to talk about the snaps? We have it here.
Oh yeah, real quick. Last week, a new version of the Snapchats were released. Of course, we picked some up. Our initial review we love them. Yeah, they're really good. Lighter.
2 thumbs up.
2 thumbs up. A lot lighter on your head. They upped the bit rate for video capture on that, so it went from 7 megabits to 20 megabits, so a lot more sharper, more clear. There's a really nice high dynamic range, and of course it works with our old prescription lenses. So we got previous, not that old. So it's prescription lenses.
You're wearing them right now.
I'm wearing them right now.
Let's look at them.
It has the transitions in them, so when I go outside, they turn into sunglasses. and definitely useful if you see all of our B-roll footage. It's all shot with just snaps because it's a lot more easier to do point of view shots when you're using two hands to hold whatever you're making. So definitely recommended. Check them out. Waterproof. We'll be testing that coming up soon, but really cool for being able to capture all of our projects as they're being made.
Yeah, this is a perfect example of like, well, what would I need a hands-free camera when you're doing something like this? Yeah, it's a lot more affordable than a $400 GoPro. And a little bit more practical than strapping it to your head. Yeah. So, you know, that's why we're using it, just to kind of document these sort of events like this, these sort of things.
Now you can totally see just how hard it was to scrape away that PVA material on that.
So, pretty cool. Nice job.
Check them out. They are available on Snapticals or
no, spectacles.com. Yeah, they're about 150.
Yeah, they have their own option for adding prescription lenses, but if you want to get something like with the prescription transitions on them, either go to glassusa.com or Rochester Optical is who I used.
Yeah, you can also get non-prescription lenses, which are like $10. That way you can use them as more of a, for the workshop, you know, like goggles, like eye protection wear.
I would spring for the $30 versions where it's no prescription. All it does is just so they can turn into
sunglasses.
So
so you use them a little bit more, Yep.
So definitely recommended for all of the point of view project stuff you want to capture.
Sweet.
Your maker endeavors. All right, I think that's going to wrap it up for this week. Thank you all for joining.
Yeah.
Coupon code for this week is makerfaire.
Yep.
Check it out. Pick up anything. It's 10% off, except for software subscription. I forget who was mentioning no more software. No, we don't sell EagleCAD anymore. That was the only software
it's free
we were
now.
selling.
You can download it, which is great. Yep, so later tonight we'll be on the show and tell. If you want to share your projects with us and the world, come on by. It's at 7:30 p.m. Eastern Time, the show and tell, and then Ask Engineer is shortly after that at 8 p.m. Eastern Time, full hour of Lamar and Phil. Get some open source news, new products, all that and more.
Sneak peek at the upcoming robotics platform.
That's right, Cricut. And then tomorrow, don't forget, John Park's workshop is on Thursdays. That's tomorrow at 4 p.m. Eastern Time. I know because I actually wrote it. Finally, there.
He'll be covering a lot more cardboard projects that we're working towards for AdaBox 08.
Yep, and last week he talked about using cardboard and copper tape to make sort of some of the resistor tools and things.
That's very cool.
Using some techniques and tips that he learned from Bunny Studios, sharing paper circuits. Very, very cool stuff. There's a trend here going on. Cardboard. Cardboard is in right now.
Yep.
All right, and don't forget, guys, all your orders support all the lovely people that work at Adafruit, the whole team. It's not no VC funding. It's all
women-owned.
Yeah.
No
VC
loans
capital,
or debt or anything like that. It's all supported with orders from you guys. So thank you all for supporting us.
Yep. Don't forget, keep it going, make it fair. And there will be one tonight too on Ask Engineer. So be on the lookout for that.
And one tomorrow as well, since all the products released come out tonight. So if you want to pick up anything new, you can still use a coupon code. Use John's code tomorrow.
Sweet. All right, well, guys, thank you so much for joining us. Good luck with all your maker endeavors. And, of course, don't forget to make a good day. With that, we'll leave you with this week's fail.
See you guys.
Bye, everybody.